Hello students, this is Brock Skaggs. I'm going to make a companion video with our position example problem 1 analytical. And so previously we analyzed this simple crane. We're trying to extend the cylinder, which is the primary actuary, to raise and lower the crane arm here. We're extending it such that point D at the very far end of the crane gets to a height of 22 feet above the ground here. And so previously we went through the analytical solution, worked through all the math, and came up with 11.23 inches of extension for the cylinder. Well, let's also do this on a graphical approach. And so with the graphical approach in this specific video, we'll use SolidWorks. And so I'll just hop into SolidWorks now, open up a part template, and we'll get inside of a sketch in the front plane there. And so I've got this nice blank canvas for my sketching environment inside of SolidWorks. And so now if I go back to OneNote, what are we actually going to do? Well, we need to basically lay out the mechanism in both the initial state, like you're seeing it now, and also the final state, when that point D has been raised to a height of 22 feet. And so this first sketch we'll draw is just the mechanism in its initial state. We'll create another sketch, and that'll be in its final state, and then we should be able to do our analysis at that point in order to actually come up with that extension. So one thing you'll notice here is that all my length units are in feet, and I'm using an IPS unit system inside of SolidWorks. And so yes, at this point I could go through, change my unit system, probably create a custom unit system to have the length unit as feet. But instead of doing that, I'm just going to keep in mind that the length units in SolidWorks will be saying inches, but in my mind they're actually going to be feet there, and so then I'll make any unit conversion that I need to after the fact. And so as far as what I'm going to start sketching, well, I need to lay out the initial configuration or initial position of the mechanism. And so I'm first going to locate points A and B. As you can see, points A and B are kind of fixed to the frame part if we just talk about the two-dimensional motion, the raising and lowering of the crane arm. And we can basically watch the motion of all the other pieces as they move with A and B as these fixed references. It's part of the frame for us. And so to locate those, notice the dimension scheme here is basically referencing this front point where that first tire is going to be contacting the ground. And so I'll just call that point the origin, and then we can use sketch points to locate points A and B. And so this is the contact point for the wheel or the tire. I'm just going to use sketch points here and here for points A and B. And so A is 4.75 units on the horizontal. And so now we'll just use the Smart Dimension tool to lay that out, 4.75 units, and then 3.75 for the vertical. So that fully defines the position of point A with respect to the origin. And then point B, we'll do the same thing. It's 8 1/4 on the horizontal. And 5 1/4 for the vertical. Alright, so if I wanted to, I could come in and I could put text in order to say, hey, this is point A, this is point B, just to keep things short for the video. Let's just remember this is point A and this is point B. And so how do we lay out the cylinder as well as the crane arm? Well, the first thing I would do is look at the geometry between A, B, and C here. We know that from B to C is going to be a length of 6.5, and between A and C in the initial configuration it'll be roughly 5.21. And so what I could do, since SolidWorks is nice and parametric, I can just draw this triangle that's going to be forming here. Right now it's all loosey-goosey and underdefined, and then I could just dimension the side lengths as needed using, again, aligned dimensions here. So 6.5 here and 5.21. Oh, be careful. This is a good case. Notice it has a vertical dimension here. I do not want that. I want the actual aligned dimension because I know the actual length of the cylinder. And you can see just by putting in the two dimensions here, I've got the angles already defined with this triangle that was A, B, and point C here, which is good. I guess the next thing we need to do is put in the rest of the arm. And so here we just basically need to extend the BC line all the way out to D. One way we could do that in SolidWorks fairly easily is just create another line segment. We can use our geometric relations here in order to make sure that those are always parallel. And then I know the overall length between B and D is 24 feet. And so just smart dimension between those 2 points. Again, make sure you've got the aligned dimension in this case, not a horizontal like this, not a vertical like this, but aligned here to be our 24 value. At this point, we've got the initial setup of the mechanism already in place. Here, if I want to, I can take a measurement here. That should be close to 17.25. Here it's 17.28 to 2 decimal places. Don't be alarmed. The reason that's off a little bit is because of this value right here, 5.21. That is a rounded value that I rounded in order to just help with the calculation on the analytical side there. And so with this, we can go ahead and proceed. And so I'll exit this sketch. One thing I'm going to do, just a good habit, is to rename the sketch. Instead of sketch 1, I'll put it as initial state. And another thing I'm going to do is I'm going to come in here, I'll right click on the individual sketch, and I'm going to change the sketch color. And so that way I'll clearly be able to differentiate the geometry after I lay another sketch on top of this. And so I've got the initial configuration and the initial position of the mechanism laid out here in red. Now I'm going to create a second sketch on the front plane. So it's basically going to be right on top of it, and this will be the final state or final position of the mechanism. And so we still have points we can reference. You can see A, B, and C here are still laid out for us. And so really all we need to do is go from point B, draw a line segment here. This line segment is the crane arm itself, so it's going to be 24 units long. And in this case, at the final state, we need point D to be 22 feet above the surface. Well, we talked about that reference surface datum as the origin. I'll basically a line drawn horizontal with the origin. And so here I can come in and just make a vertical dimension referencing the endpoint of that 24, in this case feet length of line, in order to correctly position that line segment. And so that is looking good. At this point now I can draw in the line for the cylinder. And so the cylinder is going to be connected down here. This was point A. And it's going to be connected somewhere along this line here. And so I'll just click here. Notice it's coincident along the line, but it still has this freedom here. How we're going to be able to control that is the fact that we know that measured along the crane arm from B to C, we know that intersection point is 6.5 units. And so here I can make another line dimension from that point here to this point here. Make it the 6.5. Pull this out. And now I've redrawn the mechanism in the final state. And so it's nice in SolidWorks that everything is very loosey-goosey, if you will, as it is underdefined, and you can just kind of move things as needed, and then you're just applying either the geometric relations or the dimensions as you know them in order to fully constrain your sketch. Obviously it's going to be important to fully constrain or fully define your sketches in order to make sure you have the appropriate geometry laid out. And so at this point, one thing we'd be interested in is this right here, this dimension for the align dimension. There, I guess I'll show that again. I went through fairly quickly. I'm trying to put a dimension in. I want to make sure it's aligned, and so I got to make sure I have that. When I left click, it's saying, hey, the sketch is already fully defined. This is going to be over defining it if you want to try to make it a driving dimension. Here, for this, we're just trying to read the value off, so I'll just make it a driven dimension and say OK. You can see the kind of grayish icon here. And let's go out, let's say 4 decimal places. And you can see the new length of cylinder is 6.14 feet. I believe I can also, if I wanted to have reference, I can see there, I can't get it to show, there we go, that is 5.21 feet there. And so the difference in length would just be the difference of those two line lengths. And so I've got 6.146 feet minus the 5.21 feet from the previous one. I'm just doing that on my calculator right now. That gets me to 0.936 as far as the inches, or excuse me, as feet. Here I'll go ahead and open up a calculator so you can see it as well. So really all I'm thinking here is 6.146 minus my 5.21. That gets me the change in length of the cylinder in feet, and then I'll convert it to inches by multiplying by 12 there. And so 11.23 inches for the required extension of the hydraulic cylinder there, which this should match exactly to, yes, the analytical calculation. And so at this point we've done it inside of SolidWorks as well. One thing I would suggest if you're going to be turning this in is to have this as a final state as well. You could change the color if you needed to, but in this case grayish and red is fine. And then also you may need to do a little bit of hand calculations, like in this case saying, hey, I measured this length and this length inside of SolidWorks. These are the values. I changed from those values to calculating the actual extension, so I took the difference, and then I did some unit conversion there. And so a little bit of hand calcs would supplement this graphical approach, but most of the actual work you're doing to lay out the mechanism, of course, is done using SolidWorks and inside the sketching environment there. And so hopefully this helps you in getting a handle on doing your displacement and position analysis using a graphical technique, and in this case using the SolidWorks application. Thank you for watching the video.